So now we're going to look at a data set from StatCrunch and some different sampling methods we could use to get a random sample from this data. The data set we're going to look at is in our StatCrunch group, and it's the one called Heart Attack Survival Data from 1993. One reason that we're using this one for this exercise is that this is actually a population, because this is all of the patients that had this certain set of criteria in the year 1993. And what we're going to do is look at some different sampling methods to see how we could get a random sample. For example, if we wanted to do a follow-up study on these patients, see what happened to them after they left the hospital, there's no way that we could follow all 11,434 cases. So we might want to pick a reasonable number of cases to actually follow and look at what happens to them later. Let's say that we're trying to get a random sample of 40 of these patients to follow for our study. Now, one type of sampling is called simple random sampling, and that's where basically there's no kind of organization to it. You don't divide the individuals up into any kind of groups or anything. You just randomly pick the number that you want for your sample. People do not do random well at all. There is going to be some kind of bias if you're actually choosing the numbers yourself. So there has to be some way to do this randomly. If we had fewer numbers, we could write them all down, put them in a box, and pull out 40 of them. But obviously with 11,434 of them, that's not going to work. But since we're in StatCrunch, there is an applet in here that will do random number generation for us. So this is under applets where it says random numbers. You tell it the minimum and the maximum value. Since there are 11,434 of these patients, we're going from 1 is our minimum to 11,434 is our maximum. Then we're going to put our sample size as 40. Now, sometimes we want to sample with replacement, sometimes without replacement. In this case, we want to do without replacement because we don't want to have the same patient twice. That wouldn't make any sense. If we do this, it's going to give us a list of 40 numbers. This is actually going to correspond to the rows in the data. In our patient numbers over here, sometimes they skip numbers. We don't want to make the mistake of thinking that these are patient numbers. These are just rows. The smallest one here is 775. So if we scroll down to row 775, then there's our row, and we can see the patient number for that person is 874, so that doesn't have anything to do with the patient number. Okay, that would be our simple random sample of 40 numbers. For this one, we just use the StatCrunch random number generator to get our list of 40 of these rows. If we're doing stratified sampling, that means that we divide the population up by some type of characteristic, and then we pick a certain number or a certain percentage of the individuals with those characteristics. So we divide our population up into groups, and then we take some individuals from each one of the groups. So the question here is how we could reasonably divide this up into groups. Different characteristics we have are their diagnosis code here. And one problem with this one is if you look at how many of those there are. For the different diagnosis codes, we have a huge variation in how many cases there are for each diagnosis code. For this one, there are only 128 patients. For this one, there are 4,500. So that probably wouldn't be the best way to split these up into groups. We wouldn't get a very equal representation just by taking a certain number from each group. Another thing that we could do, since we've got 2 genders and 2 different DRG codes, is we could divide this up by their sex and their DRG code. So if we look at how many there are from each group with sex and DRG together. Now this is also not evenly split up, but it's a little bit more so than those diagnosis codes were. If we wanted a random sample of 40 patients, we could take 10 from each one of these groups. So we could take 10 females with the 121 code. We could take 10 females with the 122 code, 10 males and from each of the two codes also. So that would give us our 40. That is splitting it up so that we'll get a stratified sample. But we also have to think about, when we're choosing the 10 from each one of these categories, how we're going to randomly choose the 10. Choosing them randomly, again, isn't something we can do by just looking at it and picking out certain ones. There's going to be some type of bias there. When StatCrunch under data, there's also something that will give you a sample. In this one, we want our sample to give us all of these columns. So I'm just going to highlight all of the columns. We'd have to do it for each different one of those categories. In the where box here, I'm going to put sex equals F and DRG equals 121. I'm going to have it randomly choose 10 of the people with these two criteria. We don't want to sample with replacement. That would give us the possibility of getting the same patient twice. And if we wanted to, we could open this in a new data table. I'm just going to have it put it into the same data table. It'll just put it over to the right. So if I click on compute, it added all these columns for me. So now I have a sample of 10 different patients that were female with DRG code 121. That would be the first 10 in my sample. And then to do the other ones, I'd have to go back, do the same thing again. I would just change the criteria. So this time I could put DRG equals 122. So now I have another set of columns over here. That's my second sample. So I could do that again for twice for the males, and that would give me my 40 individuals for my random sample of 40. But the thing to notice about this is that, again, when we chose the individuals from with each criteria, we had to find a way to do that randomly. To do our stratified sample, we divided population into groups by sex and DRG, and then we randomly selected 10 from each group. Let's look at a third type of sampling we could do, and that would be systematic sampling. To do systematic sampling, you take, say, every 10th individual in the list of individuals. For this population, if we took every 10th one, we'd get a lot bigger sample than 40. So for this one, we have to do a little bit of work to figure out how far we want to go in between values. If we want a sample of 40, we take 11,434, divide by 40, and we get 285 with a remainder of 34. To get our sample of 40, what we want to do is round this up to 286. And what that means is we're going to select every 286 individual from the list. If we just started with patient number 1 and after that selected every 286th one, that wouldn't be random because our selection of patient 1 for the first one wasn't random. So to make this be random, we have to, between patient number 1 and patient number 285, we have to randomly choose which one of those we're going to start with. So this is another place we could use our random number generator. So we're going to go with our minimum value of 1, our maximum value of 286. We just want a sample size of 1 because we just want it to pick out one random number for us. It chose number 171. That's the number that we're going to start with. That would start us with this row right here. And then after that, we would add 286 to that to get our next row number to choose. So after that, we're going to choose number 457. We'd keep doing that, keep adding 286 to get the next patient to choose. And when we got done with that, we would end up with 40 patients. If we were trying to do this in StatCrunch, it has a way that you can select all the rows and then go back and even put them into a different data table. That would be our systematic sample. Important thing about this is we found a way to make it random. The last sampling method we're going to talk about is the cluster sampling method. For this one, we need to divide our population up into groups and then randomly select some of those groups to create our sample. If we want to have a sample of size 40, then we need to think about what size our groups are going to be and how many groups we'll have so that we'll end up with 40 in our sample. One way we could do this is to divide our population up into groups of 5. If we have groups of 5, then we'll need to choose 8 groups in order to get our sample of size 40. The question we have to think about is how are we going to split our population up into groups of size 5, and then how are we going to randomly choose 8 of those groups? If we're taking our population of 11,434 patients and dividing them up into groups of size 5, one way we could do this is to go through the list that we have in the data set. So our first group, for example, would be rows 1 through 5. The second group would be rows 6 through 10, and so on. In order to randomly select these, we have to have the groups numbered. So we'll need to figure out how many groups of size 5 there would be. If we take 11,434 and divide it by 5, we get 2,286.8. That means that we'll have 2,286 groups of size 5 and a last group of size 4. In order to choose these, we're going to use the random number generator. For our minimum value, we'll have 1. For our maximum value, we're going to use 2,287. That means we have the possibility of getting that last group that would only be size 4. If that happens, we'll have to figure out how to deal with that. And we want to choose 8 of these groups so that we get a total of 40 in our sample. Here's our sample that gives us the 8 groups, and we'll also have to think about what each of these group numbers gives us as far as row numbers in the data. For example, in this sample we have group 3. If we think about it, group 1 would be rows 1 through 5, group 2 would be rows 6 through 10, group 3 would be rows 11 through 15. That would give us 5 of the patients in our sample. For the rest of the groups, we'd have to figure out which rows that they would correspond to. But that would give us our sample of 40.